Hey guys, in this video I'm going to be talking about motion, there we go. And obviously motion is talking about kinetic energy and how things move, etc. And in motion, what you're going to be learning about two different things. That is vector, V-E-C-T-O-R, vector quantities and scalar quantities. Scalar. Now there are different quantities in each one, and vector quantities means something in a certain direction, and scalar means just in general. So I'll talk about that later, but first we start off with speed. We all know what speed is. Is how fast you're going at a given time. So speed is, the equation for speed we know is distance traveled, or moved over the time taken. Which makes sense because that's how fast you were going at a given time, right? So that's what speed is. And speed is a, let me change the color here. Speed is a scalar quantity because you don't have to specify in what direction you're going. You just say I was going at 55 kilometers per hour, but um, you do not say I was going 55 kilometers per hour in northwest direction. No. And anyways, when you say 55 kilometers kilometers per hour, you're doing exactly the same thing. The distance, which is kilometers, and the time taken, which is hours. So that is speed. Next, we have velocity. Now, velocity is like speed, but it's a vector quantity. So it means you have to specify in which direction you're going. So for this is a it may be the same, but no, seriously, it's completely different. um for example, if you're on a racetrack, let's say, completely over racetrack, and if you start, just a second, let me change the color. If you start over here, go all the way there, and then you end over here at a speed of 55 kilometers per hour, your your average speed will be 55 kilometers per hour, but your velocity will be different because you're going in this direction and then you're going against that direction, and you're going in this direction, right? And then once you reach here, you're going the other direction. So practically you're going the other direction. So you won't have any velocity because the your average velocity will be zero, as velocity is defined by displacement. So distance traveled in a certain direction. So I'm just drawing an arrow for that. In a certain direction over the time taken. So once you go this much, and then, sorry, this shouldn't be there. Ignore that. Once you go in this direction, and then again you go in that direction, it's canceling each other out. So you have no velocity again. You're going in this curve over here, and then you're going in that curve over there. So you see, your velocity is nothing, but your speed is still 55 kilometers per hour. And then we have distance and displacement. So again, distance is distance is a scalar quantity, and displacement is a vector quantity because it's in a certain direction. Right. Next, we come with acceleration, which is a tad bit more complicated. Acceleration. Now, this can be very confusing, but it's quite simple. So acceleration is the change in speed, the change in velocity, because acceleration is also a vector quantity. It's the change in velocity over time. So that's why it's also represented by meters. Let's just say meters per second -2. So that turns into meters per second, meters per second, which can be quite confusing. But what acceleration is, let's say he has acceleration of 10 meters per second, right? 10 meters per second, -1. So every second he's increasing his speed by 10 meters per second. So when they say meters per second, so he's increasing his speed by 10 meters per second every second. Get it? So it's every second he's increasing his speed by 10 meters per second. So that's why it divides it by a second twice. And the formula for that is acceleration is the change. Obviously, this can be a negative change as well, but then it's called retardation. I'll get to that later. So the change in velocity over the time taken for that change to happen. So the time taken for this change is a second. It takes 1 second to reach from the first speed to the new speed, which is 10 meters per second more. And for change. So yeah, that's acceleration. And one this I gave you an example of increasing speed, but if, for example, when an airplane is landing, it decreases its speed by 5 meters per second, and this is called um, decreasing increasing your velocity every second is called acceleration, but decreasing is called either acceleration or or retardation. Yeah, pretty funny. Retardation. Um, there you have it, and that is practically the basics of motion. And I'll be talking about graphs and everything in another video.